Welcome to this session. In this video, let us understand about formal languages. Let me start with a simple example. Consider the natural language English. How this language had been taught in our schools. The teacher would start with alphabet of this language. Once the student was able to identify and recognize the alphabet A to Z, then the teacher would train them in framing words. With a combination of one or more words, a sentence can be framed. To form a complete and correct sentence, the grammar which was defined in English language should be used. Once the sentence is framed, it should be checked to ensure that it is a correct sentence or not by checking the grammar of that language. Now let us consider one simple example of high-level language. Let us take C++. In C++, it has a set of alphabets and symbols. Using the alphabets and symbols, set of statements with the general syntax is defined. Using the alphabets, symbols and the set of statements, we can write a program to solve a particular problem. So, the primitive of any language are symbols. Symbols are the basic building block which is predefined and it can be any characters. And the next is alphabets. Alphabets is a finite set of symbols. And then strings. Strings are finite sequence of symbols. And then with the help of above all this, we can form a language. So language is a set of strings. Now let us see about formal languages. So in computer science, formal languages are used as the basis for defining the grammar of programming languages, and also it is used to construct the compiler for that particular language. What is formal language? A formal language is a set of strings drawn from a finite set of alphabets. Alphabets of a formal language consist of symbols, letters, and that can be concatenated to form strings. We know what are symbols, alphabets, and strings. It's time to understand what is a grammar in formal languages. A grammar is in formal languages defined with 4 tuples, which is defined as G equal to N, T, P, S, where N is the set of all non-terminal symbols. Usually, the non-terminal symbols are denoted with uppercase letters. And T is the set of terminals. Terminals are denoted with lowercase letters and with some symbols. And S is the start symbol. P is the set of all production rules. In formal languages, the production rules are used to derive a string or sentence. It has the general format of left-hand side symbol derives right-hand side symbol. The left-hand side and right-hand side symbols can be terminals and non-terminals. Different types of grammars are available in formal languages. These grammars are categorized in a hierarchical order. Chomsky hierarchy is a containment hierarchy of classes of formal grammars. According to Chomsky hierarchy, there are 4 different types of grammars are available. Let me explain the types of grammar in formal languages. Each type of grammar has its own machine to recognize the strings or sentences derived from that particular grammar. As I said already, if we are framing a string or sentence from a grammar, it should be verified whether it belongs to that language or not. In Chomsky hierarchy, there are 4 different types of grammars available, namely type 0, type 1, type 2 and type 3 grammar. So the type 0 grammar is also named as unrestricted grammar. The language generated using this grammar is recursively enumerable language. The machine which is used to recognize the strings derived from this grammar is a Turing machine. The next type is type 1. This grammar is also called as context sensitive grammar, and the language generated from this grammar is context sensitive language. The machine to accept the strings generated from this language is called linear bounded automata. The next type is type 2 grammar. It is also named as context free grammar. The language generated from this grammar is context free language. The machine to accept the strings is push down automata. The last type is type 3 grammar, which is also called as regular grammar, and the language generated from this grammar is regular language. The machine to recognize the regular strings is finite state automata. The classes of grammars are characterized into 2 different ways. The first one is the type of rules that can be used to generate the set of strings, which means the set of all production rules. The second one is the type of formal machine that is capable of recognizing the language. Let us recap the types of grammar and the language accepted or generated and the machine to recognize the strings. The type 0 grammar, also called as unrestricted grammar. The language generated from this grammar is recursively enumerable language, and the machine to recognize this language is Turing machine. Type 1 grammar, it is context sensitive grammar, and the language generated from this grammar is context sensitive language, and the machine to recognize this language is linear bounded automaton. Type 2 grammar, it is context free grammar, and the language generated from this grammar is context free language, and the machine to recognize the strings is push down automaton. Type 3 grammar, it is a regular grammar, and the language generated from this grammar is regular language, and the machine to recognize this language is finite state automata. Let us see the general form of all the grammars. In type 0 grammar, the production rule is of the form alpha derives beta, where alpha is the set of terminals and non-terminals. Beta is also the set of terminals and non-terminals. This grammar has no restriction in placing the terminals and non-terminals in the left-hand side and right-hand side. For example, consider the first production rule, AC derives B. Here, the production rule is of the form alpha derives beta, and alpha is the set of terminals and non-terminal. Beta is also a set of terminals and non-terminals. Type 1 grammar, the context sensitive grammar, which has one restriction. The modulus of alpha less than or equal to modulus of beta. In other words, the number of symbols on the left hand side should be less than or equal to the number of symbols on the right hand side. Alpha and beta can be set of terminals and non-terminal combinations. For example, consider the first production rule, AC derives BC. Here, the modulus of alpha is less than or equal to modulus of beta. The number of symbol on the left hand side is 2. The number of symbol on the right hand side is also 2. Consider the second example. AC derives BCDA. Here modulus of alpha is 2 and the modulus of beta is 4. Obviously, modulus of alpha is less than or equal to modulus of beta. Type 2 grammar, the context-free grammar which has two restrictions. The first restriction is modulus of alpha less than or equal to modulus of beta. And the second restriction is alpha must be compulsory a non-terminal and only one non-terminal symbol is allowed on the left hand side. Consider the example. A derives BC. Here modulus of alpha less than or equal to modulus of beta. Left hand side only one non-terminal is available. The last one is type 3 or regular grammar which has three restrictions. The first restriction is modulus of alpha less than or equal to modulus of beta. The second restriction is alpha belongs to the set of non-terminal and only one non-terminal on the left hand side. And the third restriction is beta is of the form left regular or right regular. For example, left regular is A derives AB, where the symbol on the left hand side appears as the first symbol on the right hand side. And right regular example is A derives BA, where the symbol on the left hand side appears as a last symbol on the right hand side. For example, B derives BA, so this is a regular grammar. A derives CDA, this is also a regular grammar. Finally, there are two important hints you should always know about the machines and the grammar. Among the set of all grammar, regular grammar is a powerful grammar, and among the machines, Turing machine is a powerful machine. Thanks for watching this video.